Naturally, we'll start by importing the TensorFlow library. We will import TensorFlow as TF. Then, we will generate fake data once again. This code is virtually the same as the one we used before. There is a single line of code difference. Let's look at it. For each project you work on, you'll have a dataset. Perhaps you are used to XLSX or CSV files. However, TensorFlow doesn't work well with them. It is tensor-based, so it likes tensors. Therefore, we want a format that can store the information in tensors. One solution to this problem is NPZ files. That's basically NumPy's file type. It allows you to save ND arrays or n-dimensional arrays. Thinking like computer scientists, we can say tensors can be represented as multi-dimensional arrays. When we read an NPZ file, the data is already organized in the desired way. Often, this is an important part of machine learning preprocessing. You are given data in a specific file format. Then you open it, preprocess it, and finally save it into an NPZ. Later, you build your algorithm using the NPZ instead of the original file. So, back to the code. As you can see, we have called the inputs and targets we generated inputs and generated targets. Next, we can simply save them into a tensor-friendly file. The proper way to do that is to use the npsaves method. It involves several arguments. The first one is the file name. It is written in quotation marks. I'll call it tf_intro. Then we must indicate the objects we want to save into the file. The syntax is as follows. The label we want to assign to the ND array equals the array we want to save under that label. For us, the label is inputs and is equal to the generated inputs array. Similarly, the targets are equal to the generated targets. Note, it is not required to call them inputs and targets. If we would like to, we could call them with arbitrary names, such as rad1 and rad2. Executing the code would save the tf_intro file in the same directory as the Jupyter notebook we are using. Okay, in our next lecture, we will define our model. Thanks for watching.